students, we are going to see differential calculus and differential calculus test of differentiability. Test of differentiability, how do we check? You know the definition of differentiability. Differentiability definition we have derived, we have given as it is from the book. What is given? Based on that we have given here. Here left and here it is, this is left, this is right limit. Based on these two, we are going to carry over this problem. What is the sum is given? F of x equal to x plus 100 plus x square. Test whether f dash of minus 100 exists or not. So, for which what I am going to take? Let us take f of x. F of x is modulus of x plus 100 plus x square. Remember that this is the function given. I wish to check for minus 100. That means, here this modulus value exists only for minus x plus 100 plus x square if x strictly less than negative 100 plus x plus 100 plus x square if x greater than or equal to negative 100. Remember that there are two kinds of limiting value exist. One is negative 100 and another one is x greater than or equal to negative 100. These two values must be very careful while you are writing the functions here. So, here while you are doing like this, x square minus x minus 100, x square plus x plus 100. If x less than negative 100, if x greater than or equal to negative 100. Now, the function is defined. Problem is given like this, problem itself a problem for you, and for that you have to remove that not. Not means what? Problem, and that not should be removed. Obviously, it is easy for you to get the solution. Now, the problem test, we are going to test f dash of negative 100 is differentiable or not. F of minus 100 is differentiable or not. F of minus 100, that means f dash of minus 100, we want to check with, that is nothing but f dash of minus 100. We want to know whether it is differentiable or not, for which what we do? Same process as how we do for the previous exercise, previous sum in f dash of, what is it here? F dash of what? What we want to prove here? Here it is L of f dash of 0 here, each what? Minus 100, like this. L of f dash of minus 100, like this we have to take. Every one, the definition based on this one only. So, here the same number we have to carry over, and here we will get. Now, limit x tends to 0 minus f of x minus f of this one will become minus 100 whole divided by x minus of minus 100. F of x is, what does it mean here? Limit x tends to minus 100 whole power minus. So, f of x is, what is it here? Just take the function x square minus x minus 100 minus, here f of 100, just to substitute the value over there, that is 100 square and minus of minus plus 100 minus 100. So, getting cancelled over x plus 100. So, this is the value I got. Now, I have to apply the value over here also. So, when I am applying here, what I do, just mere substitutions value here. So, limit x tends to negative 100 upon minus, and here that is x square minus x minus 100 minus 100 square divided by x plus 100. Actually what we do here, limit x tends to minus 100 upon this. Here now you take these two, because a square term, x square minus 100 square minus of minus x plus 100 whole divided by x plus 100, remember that. So here I wish to take x minus 100 into x plus 100 minus x plus 100 over x plus 100, limit x tends to minus 100 upon this. So that means if I take x plus 100 as common, so x plus 100 bracket x minus 100 then minus 1 over x plus 100. So here both are getting cancelled, limit x tends to negative 100 upon this. So we have to apply negative value over this. It is negative 100 minus negative 100 already exists, that means minus 201 is the first limit. Let us recap for what is left limit. L of f dash of minus 100, f of x minus f of minus 100 divided by x minus of minus 100. So by way of substituting here, in the place of x square x minus 100, the second part we have to apply the limiting value, then we found out 100 square. This x square and minus 100 square play a role, and that is a square minus b square, a minus b, a plus b. Taking a plus b as common, remaining value exists, and here the place of x minus 100 minus 201. Likewise we have to apply right limit too, and right limit when I apply r of f dash of minus 100, I have to take f of x, limit x tends to minus 100 plus, and f of x minus f of minus 100. In the place of that, accept right limit. So just you have to apply the value, then you will get the answer. Let us see, we have to take the other function for right limit. The right hand side limit, what is the right limit? R of f dash of minus 100. So because we have to test the function whether it is exist or not. So r of f dash of minus 100, limit x tends to negative 100 plus f of x minus f of minus 100 whole divided by x minus of minus 100. Once again the same thing continued here, no other changes, only the function only is thing. So here f of x minus f of 100 here. So let us take this, and what is the function here? The function is x square plus x plus 100. Here only the changes will occur, limit x tends to minus 100, and here x square plus x plus 100 minus, now this part of minus we have to apply, minus 100 square, here minus 100 plus 100 whole divided by x plus 100. Remember here also minus 100 and plus 100 getting cancelled. Here it is only thing we have to check with the numerator part. So here what is it? X square. So once again we are going to apply the value. Now let us take limit x tends to. So here directly I can apply here minus 100 square x square, x tends to minus 100. So in this value x square plus x plus 100 minus this 100, we can take it as 100 square whole divided by x plus 100. Now you take this and this as common term. Now x square minus 100 square plus x plus 100 whole divided by x plus 100. Limit x tends to minus 100. Here also x minus 100 and then x plus 100 plus x plus 100 over x plus 100 now. Like this I got the value now. So now when I take the value as common term, what happened? X plus 100 bracket x minus 100 plus 1, because these two are common term. If I take, then what else will have? So these two getting cancelled. Limit x tends to minus 100, that is right. Limit x tends to minus 100 upon this. Now you can apply now. Here what is it? Minus 100 plus 1. What will get? Minus 100 plus 1. You will get 200 plus 1, 199. See, the initial value for left limit we got minus 201, and for the right limit r of f dash of negative 100, we got this. From 1 and 2, what do you see? L of f dash of minus 100 is not equal to r of f dash of minus 100. That means f is not differentiable at the value. F is not differentiable at x is equal to minus 100. So this is the conclusion of this problem. This problem, what you can see, only the cases you have to factorize the terms now. The x square minus 100 square. After doing the manipulation, directly you cannot substitute the value over the value of x. Then you may have once again is a problem. So in the instead you have to factorize. After factorizing, take the common term and then you apply the limiting value. After limiting value, you can find out what you got for left, minus 201. What you got for right limit, you got minus 199. So after knowing about these two results, if at all equal, we are going to say it is differentiable. Since it is not equal, obviously it is not differentiable at x is equal to minus 100. This ends the problem.